Okay, number 7, guys. Let's check it out. So it looks like we have a curve here and an area underneath it. So this is probably integration. So figure 3 shows a sketch of part of a curve with this equation here. The finite region S, which is bounded between 2 points, 0 and whatever this corner here, which we probably need to find out, is shown in figure 3. Find, okay, A, the integral of this. Alright, so this is just standard integration. Well, we can just do it here. To integrate, you just raise the power by 1 and divide it by itself. So for example, this is going to be 3x squared power 2 over 2 minus x, and then raise the power 3 over 2 by 1, so add 1 to it, so you should get 5 over 2. You could use decimal 2.5 if you like, over 5 over 2. And that's it. Now, because you're integrating and there's no limits, we must always add plus c, and you're done. I mean, just to make it a bit nicer looking, and because I'm guessing we're going to use the result in part B, I would probably just convert this to a decimal or something, just to make it easy. So the first one, 3 over 2, we can just say is 1.5x squared minus, bring this to the top line, so it'll be 2 on top, so it'll be 2/5, which is 0.4x to the power 5 over 2. Just say 2.5, yeah, plus c. Both is correct, doesn't make a difference. Okay, part B. Find the area of S. Alright, let's do it. So to find the area of S, we need to first see when the curve intersects with the x-axis. So when it does, this means that the curve intersects when the y-coordinate is 0. So it looks like we're going to do a bit of maths here first to find the limit. So let's solve the curve equation when y is 0. So effectively, this equation is equal to 0. So 3x minus x to the power 3 over 2 is 0. Now what do we do here? So we could firstly just, factorize x out, which I think is easy. So factorizing x, you're left with 3 inside minus, so this is like 1.5. If you take away an x, you take away one of it, so you're left with 0.5. So you have x to the power of 0.5, or half, equals 0. Now this means two things. This means that we have firstly one coordinate, means when x is 0. We also have this term when it's 0. So we're going to use the middle term because x0 is clearly over here, the origin. So the second term, 3 minus x to the power 0.5 is 0. Let's do it, yeah? Let's work it out. So solving this one, I'm going to put it down here. We have 3 equals x to the power 0.5. And to solve this one, we'll just find the 0.5 root. So in your calculator, just write the root of 0.5. Or square it. Either way, you get 9. Okay. And the reason why I write like this is because it's just to make it easy and consistent in case the number was negative, so you can always root it. Doesn't matter what it is. Okay, so this means now the x coordinate is 9 here. So all we have to do, guys, is just integrate from 0 to 9 of this equation. And since we already integrated over here, we can just find the area of B. Part B. So part B is S. So we can say S now equals the region S equals the integral from 0 to 9 of the curve, which we already know, and we've already solved it actually. And yeah, since we already solved it, we got this solution here. The only difference is now is that we have limits from 0 to 9. So instead of having plus c, we will need to substitute 9 first and then 0. So we're gonna pretty much work this out. X to the power 2.5 between 0 and 9. Yeah, that's it. So I guess we can chill here. So first things first, you plug in the value of 9. If you plug in the value of 9 into this equation, so yeah, tip, if you guys never done this before, when you substitute the value, when you have numbers like this, you always substitute one number first, the upper value, like 9, and then you substitute the below value 0, and then you subtract them. So plug in 9 first, you would get 243 over 10 in your calculator, and then substitute the value of 0, you will get 0. So then you would write it like that. The value at 9 minus the value at 0. And of course, this will give us 24.3 or 20 or that over 10. That's it. Easy. Very easy.